Hi everyone, welcome to Gnan Cloud Garage. In this session, I'm going to talk about why do customers choose enterprise grade Kubernetes platforms. So this is session one. I'll quickly run through the basics of containers, Kubernetes, and I'm going to introduce Red Hat OpenShift. This is one of the enterprise grade Kubernetes platforms. Okay, and here is the agenda. Before we going to understand the main question, why do we customers choose enterprise grade Kubernetes? Let's quickly recap one of our known point. What is the evolution of modern applications and container technology, and what are the differences between virtual machines and containers, and what are the containerization challenges, and why do customers choose enterprise grade Kubernetes, and why do customers choose specifically Red Hat OpenShift with the HPE GreenLake model, and what are all the available enterprise grade Kubernetes platforms. Okay, let's start with the first question. So when we plan to know about evaluation of modern application, how the application is developed since 1982 until now. So the procedure is like in 1980 to 1990 year, most of the infrastructure, we call it as a traditional infrastructure, and all the infrastructure consists of compute, network, storage, firewall, and other devices, and application is running on a directly on bare metal, but to run the application we need a operating system first. On top of the operating system we can run the application, and this architecture we call it as a monolithic application architecture. And to develop this software application, the procedure during this era we call it as a waterfall model, and later on there are some challenges with the waterfall model, so the development process is changed to the agile methodology, and even the infrastructure also evolved. That infrastructure from 2000 to 2009, the main innovation is virtualization. So after virtualization coming to the picture, the most of the infrastructure cost is saved. Okay, capital expenditure is saved. And how it is saved is, instead of running a one OS on same on bare metal, within one ESX box we have started running a multiple virtual machine, so that our hardware is providing a better hardware utilization, and our instead of using a hundreds of physical servers, that physical server count also reduced when we migrating from where monolithic application architecture to virtual infrastructure. Okay, and application architecture we call it as a tier based architecture or n tier architecture. And example, I took the application as web application is separate and application server is separate, and DB is running on a separate VM. This is a tier 3 tier architecture. And this process, software development process, we call it as a agile methodology. Again, to address some of the challenges within the application, like a web tier based architecture, again the infrastructure is evolved. Even host based infrastructure, now it is changed to the cloud based models. So within the cloud infrastructure we have a different type of cloud based models. Like if you are running in a on premises, we that is nothing but a private cloud. If you are, we also have a models like a hybrid cloud. If we have a public cloud, if we have mixed with multiple cloud, we call it as multi cloud or cross cloud infrastructures. And even the application, earlier it is running on directly on one system, operating system. Later it split it into a tier based. Now it is running like a container. Container means it is a software package running on a any of it's a kind of a compute unit, one small compute unit running with software package. Okay, and this can be run it on virtual machine or we can run it on a physical server, but most of the organization they prefer to run container on a virtual machine guest operating systems. Okay, earlier for each application we need a one VM, but now multiple applications we can run on within virtual machine guest OS containers. Okay, so the infrastructure cost is reduced again. And this architecture we call it as a microservices architecture. And how they are developing the software is using the DevOps best practices. Okay, development and operation teams integrate and working together and providing a solution. Okay, and earlier waterfall method, it may takes months to years time. Later on, it changed to weeks to months time. Now it's days to within a weeks we can complete the application release process. Okay, now let's talk about most of the customers these days. When we have any conversation with the leadership team or any of the application owners or C-level team, most of the customer engagements and conversations, the main concepts are these four concepts. They will talk about cloud operating models, they will talk about the containerization, and containerization they will ask for a enterprise grade Kubernetes, and they will also talk about architectural models, microservice architecture, and how they implement the process and all using the DevOps methodology. So these four concepts are common these days. So that is the reason. First, let me introduce the container terminology, and then I will talk about the enterprise grade Kubernetes. Let's say container terminology. So within the container terminology, the first key definition is what is container. So container means an application packaged with the dependencies. Like if you want to run one application, we can run the application. The first application is, let's say, container A. Within a container A, we have application one. To run that application, we have application one dependencies. For example, if you have a Microsoft Office, that's office application, if you want to run, we need even operating system. But instead of running the complete operating system, we can take only the necessary dependency files and library, dynamic link library files, and those files only it will help to run that application, Microsoft Office application. Similarly, if you take any of the other applications also, instead of using the complete OS dependency, they disassociated from the operating system or decoupled from the operating system. They make it as a small application package so that it's a portable. We can move it from on premises to private cloud to public. Anywhere you can run the container applications. So same, if you take another container B, we have application 2, and it is also have application to necessary dependencies, okay, and library files. And where we can run this container. So container, if you want to run, we need a container host. That container host can be either a virtual machine or any of the physical server. So a VM or physical machine on which container runs. So that means any of the most of the scenarios, all the organizations, they are running the containers on a virtual machine environments. So that's why I took the example of virtual machine guest OS container host is running. But if you want to create a virtual machine, we need a hypervisor, and hypervisor is require a physical infrastructure. So one of the hardware we can install the hypervisor, and it need a network device and storage devices. Okay, and another key point is container engine. So a runtime engine that manages the containers on the container host. So we need a one container engine to manages the containers. Here one easy example is, if you have one ESXi host, we can run a using vSphere host client. If we have multiple ESXi hosts, we are using a management tool that is called vCenter server. Similarly, normally if you have one container, we can manage easily. If you have two container or more than two container, to manage these containers and control, we require a container engine. That point only we mentioned here. To this container engine mainly to the a runtime engine that manages the containers on a container host. Okay, but normally container engine, most popular container engine is Docker. So the most recognized runtime engine for container support is often used as a synonym for many aspects of container technologies. Okay, so container engine, wherever we heard this word, that is nothing but a Docker only. But still, why we are going for a Kubernetes means within this container engine or Docker, there are some challenges. So let's, before explaining the challenges, let me explain what are the differences between VMs and containers. So normally we know virtual machine means it is a software generated machine and looks like a physical machine. And the container means it is a software package and it's a kind of a portable package only. It can be run anywhere. And virtual machine, so if you want to create virtual machine, we need ESX hypervisor, and on top of ESX we can create the VM, run the guest operating system, and run a application. But when it comes to the container, within the guest operating system, virtual machine guest operating system, we can create multiple containers, container A, B, and C. Okay, and the key difference are an application used to be built on virtual machine, and VMs offer the advantage of secure, reliable, high availability. Okay, and virtual machine scheduled by the hypervisor, and also it runs on a hypervisor. And starting a virtual machine, that means if you power on a virtual machine means that starting a operating system, normally it will take time seconds to minutes. The same comparison with the container is container application, we call it as a modern applications or cloud native applications. These applications are built on container, and container runs on a virtual machine. And containers offer the advantages portable, packable, and easier to update. Yes, and scheduled by the container host operating system and run by the container host operating system. And starting a container means starting the application process. So that application process time, when you compare with the virtual machine, here time is reduced milliseconds to seconds. Okay. Now let's talk about what are all the containerization challenges. Even though if you have multiple containers within the virtual machine guest OS, there are some features are not available. Those features are load balancing, security, provisioning, and also the high availability and scaling. So in order to address these challenges, what VMware did is they introduced the concept called Kubernetes. So if you have a container engine within our environment, we also need a Kubernetes. So the Kubernetes is like it will address all these challenges. So the same point I mentioned here. Kubernetes is a solution for the container challenges, and Google developed orchestration for container. Orchestration is automating many tasks together. And in other words, Kubernetes means it is a container orchestration platform. Okay. And this icon in the Kubernetes icon, if you see the normal cruise, how the captain's steering, the same icon only we are using in a Kubernetes. Okay. Now let's talk about Kubernetes importance. Let's say now in our earlier, we most of the organization they're talking about virtual machine, but now the trend is changed. Every organization is talking about Kubernetes. So Kubernetes is the next wave of infrastructure. But Kubernetes is like a open source product only, but companies also require additional support along with Kubernetes. So that is the reason customers choose a enterprise grade Kubernetes. Okay, let me try to explain with a one example. So why do customers choose enterprise grade Kubernetes means, suppose if I am take a one example of engine. If you have a engine, let's say this is a car engine. Only if you have only engine, there is no use. We need to add all the additional parts like seats, steering, and all the parts we need to add. Then only we can make the car. Even if you have one Docker or Kubernetes container engine, there is no use. Okay, so that is the importance. Even if you compare here, the Kubernetes is if you want to run it on bare metal virtual machine, or you can run it on any cloud environment, it comes with only Kubernetes cluster services, basic networking, and ingress. It's like a only engine only. There is no use. We need definitely a additional parts, or in another words, we need a additional Kubernetes services and tools. So if you see within that engine, if you add all the additional component, it looks like a car shape. That is nothing but a Kubernetes plus native services. So those native services are minimally logging, metrics, image registry, mainly to consist of all the images, and monitoring, service mesh, development tools, and also CI/CD pipelines. This all the additional components we have to depend on all CNCF certified vendors, but all are the open source tools only. So that means multiple vendor dependencies dependency in this solution. But most of the organization they also always look for a optimized solution. That solution is Red Hat OpenShift. So if you see this assembled car, the completely with a one principal vendor, they make up the car. That means definitely they will provide a maintenance and additional support services. So same scenario, if you compare with the Kubernetes, instead of getting the tools from other third-party vendors, Red Hat itself providing the complete bundle package. So on top of Kubernetes, we are running a OpenShift cluster services, and it's providing networking, router, OLM, and that means lifecycle management, logging, metrics, whatever we are getting from third-party tools, all are available from a Red Hat authorized vendor. This is one of the CNCF certified. Even enterprise-grade Kubernetes, this is one of the main leading vendor, and this is a self-managed Red Hat OpenShift. So this is a recommended method to use it in a production environment. Suppose customer also looking for a additional infrastructure support and additional advisory and professional services and managed services, they may go for a full service model. So full service model means Red Hat OpenShift directly running on a HPE infrastructure. That means server plus storage. So with that, there we also need get a additional support and operations support. That means managed services and implementation, design, deploy, and implementation. All the services are getting from a HPE vendor, Hewlett Packard Enterprise. So organization prefer to choose any of these one solutions. Okay. Now, another key point is, why do customers choose Red Hat OpenShift with HPE GreenLake? HPE GreenLake mainly like a pay as you go model. So instead of paying for a complete server hardware cost, we just pay monthly basis whatever the usage we used. Even if you run the Red Hat OpenShift on our HPE GreenLake servers, that servers usage bills only we have to pay to the monthly basis. So same like our house home power bills. Okay. Now, the main benefit of why do customers choose Red Hat OpenShift with HP GreenLake is, together HP GreenLake with Red Hat can tackle any workload in a cloud consumable manner. Okay, and the leadership in Kubernetes market and customer adoption in the community, and fully managed cloud services providing full stack management from Kubernetes experts, and a comprehensive platform from Linux to Kubernetes infra to development and operations tools, and consistency across all public cloud, data center, and edge environment. Even this solution you can implement on a edge location, on-premises data center, private cloud, and so on. Okay, and it is also providing a facility to integrate with the public cloud environments as well. Okay, now let's talk about what are all the available enterprise grade Kubernetes platforms along with Red Hat OpenShift. Okay, let me elaborate the additional tools. Normally, now we got an idea why organization will not use only the Kubernetes. They will go for a enterprise grade Kubernetes only. So those enterprise Kubernetes, let's say VMware, the authorized tool is Tanzu, and Red Hat OpenShift, HPE. HPE also have an authorized enterprise grade Kubernetes tool that is called Esmeralda, and public cloud Microsoft Azure have a AKS, Azure Kubernetes Service, and Google have a GKE, Google Kubernetes Engine, and AWS have AWS EKS, Elastic Kubernetes Service, and we also have SUSE Rancher. And if you want to quickly remember, means the Tanzu means this is the usual logo for VMware Tanzu, and Red Hat OpenShift. Whenever you see this logo, that is as a Red Hat OpenShift, and this is for a HPE Esmeralda, and we have Azure Kubernetes Service logo, and this is the main logo for a Google Kubernetes Engine, and this is for the Amazon EKS, Elastic Kubernetes Service, and SUSE Rancher. Okay, so most of the organization depends on their business requirement. They choose one of the enterprise grade Kubernetes platforms. Let's say if the customer is running on with a VMware vSphere environment or vCF platform, they definitely prefer to go for a Tanzu solution. And if the customer environment running with Red Hat Linux flat environment, definitely they go for a OpenShift. And some customers may choose SUSE Rancher, and some customers may choose HP Esmeralda. If the customers are from public background, public cloud background, they may go for any of the respective public clouds. Okay, depends on their business needs. Okay, hope you got an idea why do customers choose enterprise grade Kubernetes platforms. Okay, that's it for today. Thank you. Please do view, like, share, and subscribe to the Gnan Cloud Garage channel if you are watching this video first time. If you're already subscribed, I appreciate all your support. Bye for now.